Hello my dear students, I warmly welcome you to CR Digital Classes. In this lecture, we are going to discussing problems based on Lagrange's interpolation formula. Okay, in the previous lecture, we derived that the derivation of the Lagrange's interpolation. So now we are going to discussing the problems based on this Lagrange's interpolation formula. So now see here, in this lecture, total 3 problems are there. So we are going to discussing 3 problems in one lecture. So you can see using Lagrange's interpolation formula, find the form of the function y of x from the following table. Okay, we have to find out the form of the function y of x. That means, okay, so this is the given data x comma y, that is the tabulated data 0 1 3 4 minus 12 0 12 24. Okay, so here you can observe carefully, whenever we are going to use Lagrange's interpolation formula, the main thing is the x values are unequal or equally spaced. So if you observe carefully, 0 to 1 and 1 to 3 and 3 to 4, these are 4 values are unequal intervals, okay, unequally spaced values. Okay, so for these types of values also we can use the Lagrange's interpolation. So you can take, now we can start the solution. Given table, we can write it as x values 0 1 3 4 and y values minus 12 0 12 24. So this value you can write x0, x1, x2, x3. This value y0, y1, y2, y3. But why? Because so we have to substitute those values in the formula. So from the table we have y of 0 is equal to minus 12, y of 1 is equal to 0, y of 3 is equal to 12 and y of 4 is equal to 24. So clearly from table, x minus 1 is the factor. Okay, clearly from the table, x minus 1 is the factor since y is equal to 0. If you observe carefully this one, okay, if you observe this one, y of 1 is equal to 0. Okay, whatever the function it might be, okay, whenever you take one function y of x, that value is equal to 0 means that x value is the root of that function. X value is the root of that function whenever y of x is equal to 0. Similarly, here we have y of 1 is equal to 0. Y of 1 is equal to 0 means here 1 is the root. 1 is the root of the given function. That function is whatever. Okay. With the using of this loophole, we can write x minus 1 is the one linear factor. That means whenever you write x is equal to 1 is the root of the given equation, then x minus 1 is equal to 0. Then x minus 1 is the one linear factor since y is equal to 0. Next, you can see here, let I am taking that function as y of x is equal to one linear factor. We have x minus 1 by using given table, and remaining equation form I am writing capital R of x. Okay, we don't know what is that equation, but from the given data we have one linear factor as x minus 1 and the rest of the term is R of x, that is taken as equation number 1, be the required equation which holds the values of the given table. Okay, where R of x is the, from this condition you can get R of x is equal to y of x by x minus 1. Now our aim is we have to find out the capital R of x value. Okay, after finding that R of x value, if you substitute in equation number 1, then you will get that value of that y of x. So then the values of capital R of x can be obtained as, okay, whenever you substitute x is equal to 0, then R of 0 is equal to y of 0 by 0 minus 1. What is the y of 0 value? Minus 12 by minus 1, that is equal to 12. So therefore R of 0 is equal to 12. Next, already x we have taken x is equal to 1, and next x is equal to 3. So for x is equal to 3, R of 3 is equal to y of 3 by 3 minus 1. Y of 3 is equal to 12 by 2, 6. So therefore, next for x is equal to 4, R of 4 is equal to y of 4 by 4 minus 1, that is equal to 24 by 3, that is equal to 8. So therefore, after using these all values, again the tabular form of the above values is, okay, for above 3 values, for x is equal to 0, x is equal to 3 and x is equal to 4. This total table belongs to R of x, where the function y of x is equal to R of x. Okay, x minus 1 into r of x. So therefore function is r of x. So therefore x is equal to 0, we have the r of x function 12. For x is equal to 3 we have 6 and x is equal to 4 we have 8. After getting this table, now you can see x0 and x1 is equal to 3 and x2 is equal to 4. Next to r0, r1, r2. These are the values r1, r0 and r2. Now by applying the Lagrange's interpolation formula is given as r of x is equal to, okay, x minus x1 x minus x2 by x0 minus x0 into x0 minus x2 into r0 plus x minus x0 x minus x2 by x1 minus x0 x1 minus x2 into r1 plus x minus x0 x minus x1 by x2 minus x0 x2 minus x1 into r3. This is the total formula. Why? Because here we have three points. What is that point? x0 comma y0 is the first point, x1 comma y1 is the second point, and x2 comma y2 is the another point. For 3 points, this is the equation. In the general proof, we have taken in place of r of x Ln of x. That is, in general proof we have taken L2 of x. L2 of x is equal to L0 of x y0 plus L1 of x y1 plus L2 of x y2. In general proof we have taken for the 3 points. So now in this problem, substitute in the corresponding values from the table 2. Okay, so this is the table 2. Substitute in the corresponding values in the above equation. So therefore r of x you will get, you don't know the value of x, but you know the value of x0, x1 and x3, x2 and r0, r1 and r2. Substitute all those values, so and simplify, you will get capital R of x is equal to one quadratic equation, x square minus 5x plus 12. Okay, so therefore that is taken as equation number 12 by substituting the all corresponding values in the above equation, and if you simplify that you will get that equation r of x. Now substituting equation number 2 in equation number 1. What is that equation number 1? Y of x is equal to x minus 1 into r of x. Okay, so therefore where r of x is equal to x square minus 5x plus 12. Okay, so now if you multiply these two values, then you will get one cubic polynomial in terms of x. So therefore y of x is equal to x cube minus 6x square plus 17x minus 12 is the required equation of the given data. Okay, by using the one loophole, that is y of 0 is equal to 1, we obtain that the solution of the given tabulated function. That solution is y of x is equal to x cube minus 6x square plus 17x minus 12. Okay, now after getting this equation, you need to cross check once. Why? Because if you substitute x is equal to 0 and x is equal to 1, x is equal to 3, x is equal to 4, you have to get the same values only. Okay, so in this format, for equally spaced values or for unequally spaced values, we can find the Lagrange's interpolating polynomial. Okay, this is called the Lagrange's interpolating polynomial. So this is the one type of problem. Now here you have another question. This question deals with the inverse interpolation. This problem deals with inverse interpolation. If y1 is equal to y suffix 1 is equal to 4, y suffix 3 is equal to 12, y suffix 4 is equal to 19 and y suffix x is equal to 7, find the small x value. Okay, in the examination also you will get the problems in this format also. So this problem is not a tabulated function. Okay, so we have to write that problem into table format. So now you can see the solution. Given data is x values are the suffix values of y. Okay, y suffix values are called x values. So therefore this 1 and 3 and 4, these are the x values. So therefore 1, 3, 4 are the x values, and the corresponding values for 1 you have y1 is equal to 4, y3 is equal to 12 and y4 is equal to 19. And again you also have 7 here, but we have to find out this x value. Okay, so now we have to find out this x value. So therefore here x0 is equal to 1, x1 is equal to 3, x2 is equal to 4, y0 is equal to 4, y1 is equal to 12, y2 is equal to 19, and small y is equal to 7. Instead of taking y3 is equal to 7, okay, small y is equal to, we are taking 7. By Lagrange's inverse interpolation formula, now to solve this type of problems, we are going to use Lagrange's inverse interpolation formula. What is that equation? In the general proof, we discussed that by interchanging x and y in equation 11, we'll get that equation number 12. That equation number 12 is called the inverse interpolation formula for the Lagrange's. So, same that equation number 12 in the general form proof. So, we are writing here x is equal to, where we are interchanging y with x, x with y. So, therefore, that is x is equal to y minus y0, y minus y2 by y0 minus y1, y0 minus y2 into x0. So, in this format, you will get the inverse interpolation formula for Lagrange's. Substitute the corresponding values from the table. Okay, so therefore, x is equal to, we need to find out that the x value. Okay, so substitute all the corresponding values from the given table and simplify. You will get x is equal to 1.8572. X value is x is equal to 1.8572. This is the value for up to 4 decimal places. We can approximate this value up to 2 decimal places as 1.86. Okay, 1.86. Since the polynomial y of x is equal to x square plus 3, therefore the actual value of x is 2. Okay, so if you observe carefully, the polynomial for this equation is, the polynomial for this, the given data is y of x is equal to x square plus 3, x square plus 3. So how you can get y of x is equal to x square plus 3? If you substitute the values, x is equal to 1, 1 square plus 3 is means y of 1, you will get 4. Is it correct only? Right. Next for y of 3, okay, 3 square plus 3, okay, it is also 12. Next for y of 4, 4 square plus 3, 19, okay, 16 plus 3, 19. Similarly, you will get that, to get that the value, to get that y suffix of x is equal to 7, to get that y suffix x is equal to 7, you need to substitute that x is equal to 2, x is equal to 2 in that equation. Therefore, y of 2 is equal to 2 square plus 3, then only you will get 7. That means by inverse interpolation formula, we can get the approximate, nearly approximate values of the small x. That is called x is equal to 1.86 ante then meaning enti, x is approximately equal to 2 అని అర్థం అన్నమాట. So therefore, whenever you substitute x is equal to 2 in the given equation, then you will get the value is 7. That is the problem based on the inverse interpolation. Now we are going to discussing another problem based on the Lagrange's interpolation only. Find the Lagrange's interpolation polynomial, okay, of degree 2. Degree 2 అంటే మనం ఏం చేయాలి, ఇక్కడ quadratic equation ని find out చేస్తాం. Approximating that function ఏమి ఇచ్చారంటే ఇక్కడ function y is equal to natural logarithm, okay, anti logarithm అని కూడా అంటారు. Okay, y is equal to ln of x defined by the following table values. Hence determine ln of or natural logarithm of 2.7. Define that natural logarithm of 2.7 value ని మనం derive చేయాలి. So therefore, see the ఇక్కడ ఏంటంటే మనకి given data x values ఇచ్చాడు 2, 2.5 and 3.0. Given data is equally spaced. Small h is equal to 0.5. By clearly observing we can say that, and y is equal to ln of x values also we have. So now you can see the solution. From the given table, you can write x0 values and y0 values, and by Lagrange's interpolation polynomial we have 3 points, x0 y0, x1 y1, x2 y2. So then you can take that L2 of x, okay. Second Lagrange's interpolating formula, that is L2 of x is equal to L0 of x y0 plus L1 of x y1 plus L2 of x y2. That is taken as equation number 2, where you know very well L0 of x, okay, L0 of x is equal to formula. In this formula, substitute the x1, x2 and x0 values and simplify. You will get L0 of x is equal to one quadratic equation, 2x square minus 11x plus 15. That is taken as equation number 12. Now L1 of x value, similarly L1 of x is equal to x minus x0, x minus x2, x1 minus x0, x1 minus x2. Now in this equation, substitute the corresponding values except to x in that equation, you will get, okay, by after substituting the all those values, L1 of x, you will get again another quadratic equation. L1 of x is equal to minus of 4x square minus 20x plus 24. That is taken as equation number 3. Similarly, L2. L2 of x is equal to, this is the formula. Whenever you have suffix value 2, L2 of x is equal to, so మీకు suffix లో 2 ఉంటే ఇక్కడ denominator లో కూడా x suffix 2 తోటే స్టార్ట్ అవుతుంది అనమాట. So therefore, so that is the L2 of x formula. Substitute the corresponding values and simplify that. L2 of x is equal to 2x square minus 9x plus 10. That is taken as equation number 4. So now substituting equation 2, equation 3, equation 4 అన్ని మనకు quadratic equations వచ్చాయి. So substitute all those quadratic equations in equation number 1, that is in L2 of x. So therefore then L2 of x is equal to, this one is the L0 of x and this one is the y0 value, and this one is the L1 of x, that is the equation number 3, and this one is the y1, and this one is the L2 of x, and this one is the y2 value. Y2, y0, y1, y2 we can obtain from the given table. So substitute by simplifying, you will get one quadratic equation, okay, with the real numbers or decimal numbers are the coefficients. So therefore that is taken as equation number 5. L2 of x is equal to minus 0.08164x square plus 0.81366x minus 0.60761. That is taken as equation number 5, which is the required polynomial of degree 2 or quadratic polynomial. అంటే మీరు ఇప్పటిదాకా మీ ఇమాజినేషన్ లో ఏముంటదంటే, ఈక్వేషన్ వస్తే ఖచ్చితంగా దాని కోఎఫిషియెంట్స్ ఇంటీజర్స్ లేదంటే రియల్ నెంబర్స్ ప్రైమ్ నెంబర్స్ అయితే అనుకుంటారు, కానీ ఫస్ట్ టైం ఒక డెసిమల్ నెంబర్స్ తో కూడిన ఒక క్వాడ్రాటిక్ ఈక్వేషన్ నెంబర్ కూడా వస్తుంది. ఓకే, సో బట్ ఈ ప్రాబ్లం లో మనకు లెగ్రాంజెస్ ఫార్ములానే యూజ్ చేస్తున్నాం, ఈక్వల్లీ స్పేస్డ్ ఎక్స్ వాల్యూస్. ఇంతకుముందు ప్రాబ్లం లో అన్ఈక్వల్ స్పేస్డ్ ఎక్స్ వాల్యూస్, ఇప్పుడు ఈక్వల్లీ స్పేస్డ్ ఎక్స్ వాల్యూస్ అన్నమాట. సో నౌ సబ్స్టిట్యూటింగ్ x is equal to 2.7, మనకి ఎందుకంటే ప్రాబ్లం లో ln ఆఫ్, ఓకే, ln ఆఫ్ 2.7 వాల్యూని ఫైండ్ అవుట్ చేయమన్నాడు. ఓకే, సో దేర్ఫోర్ ln ఆఫ్ 2.7, x is equal to 2.7 కాబట్టి, సో దేర్ఫోర్ ln ఆఫ్ 2.7, ln is nothing but L2 of 2.7. సో దేర్ఫోర్ ఎక్కడైతే మీకు x ఉందో అక్కడ 2.7 ని సబ్స్టిట్యూట్ చేయండి ఈక్వేషన్ నెంబర్ 5 లో. సో ఆఫ్టర్ సబ్స్టిట్యూషన్, ఇఫ్ యూ సింప్లిఫై విత్ సైంటిఫిక్ క్యాల్కులేటర్, ln of 2.7 value is 0.9941164. okay, that is the very approximate, very near value is equal to, okay, this value you can write equal to 1. ln of 2.7 is equal to 1, but actual value of ln of 2.7 is this one. Originally if you calculate in the scientific calculator, you will get this value as actual. Original value is 0.9932158 and the approximate value is this one. There is a lot of difference, okay, there minute difference only, but it is lot. So therefore you can write that error is nothing but true value minus approximate value. So therefore error is nothing but true value is nothing but what we have the actual value. Okay, so this is the actual value and this one is the approximate value. So therefore if you apply the subtraction, so therefore you will get 0.0008646. so that is the error value, and that one is the, this is the ln of 2.7 or natural logarithm of 2.7 is equal to 0.9941164. in this format we can also find the error of the given function and values of the any function, and we can also derive the interpolating polynomial of order greater than or equal to 2. In this method we can use the Lagrange's interpolating formula for equally spaced and unequally spaced intervals. In the examination, if you get any question based on in this method, you have to do the same process. Okay, so you have to learn the formula first of all. After that you have to substitute the corresponding values. That is the major problem. So I hope you understood this lecture very well. In the next lecture we are coming with another interesting and important topic. Okay, make a perfect practice, prepare well. Until bye, thank you. This is K Viresh signing off.